Hello friends, welcome back to this channel again. This time there is a very different topic on Elastic or Elasticsearch as we used to call it earlier. And to take us through this journey, or have conversation on this topic, I have my good friend and a good colleague Amit Subhedar from BMC Software. Hi Amit.
Hey Samir, hi. Nice
Yeah.
to be in the show. So looking and absolutely was when this channel was launched, I was waiting when I'll become part of the series. So very happy to be
I would
and
say we are
privileged to be
privileged.
invited here.
I would say we are privileged to have you here because I have worked with you and I know, your levels of expertise and your level of knowledge. So we are really glad you are here. And Elastic is a
Same here,
fantastic
same
topic.
here.
Yeah, it's a fantastic topic, and I think we have seen it growing over the years, many years, and starting from a maybe a simple alternative for text search to the level that it is today, and it has to offer a lot, and that's really the topic that we like to go into, right? What is it that Elastic can really offer when you are building an enterprise class, very complex software, and it has multiple roles to play. There is not just one use case, there are so many use cases, and that's what we want to understand, friends, over here. So, Amit, let's get started with our conversation. And I think the first thing probably to
Sure.
look at is, like Elastic, Elastic as a company, how it has grown, its current state and its current ecosystem, where it stands. And maybe that's a great topic to start with, probably.
Absolutely, absolutely. So it has been one of the excellent journeys for a pure tech company, right? So this really started
Yeah.
as a pet project for Shay Banan, which is a founder, and then lot of people joined along the way. So it is a very interesting story, and I think I would request you viewers to go through their story as well. I don't think we'll cover it in a great length here, but the way he started as a pet project to support his wife's recipe or the online recipe business, he
Yeah.
used the open source Apache Lucene as a backend and then started developing front end, and plus the actual query wrappers and all that, the storage optimizations. And along the way, the if you see the Elastic today, right, we refer it as a ELK stack,
Yeah.
whereas Elasticsearch, Logstash, and Kibana. All Logstash and Kibana is something that the folks joined to share as part of their open source initiatives. And then around 2012 or so, they formed a company, and then they 2015 or so went big. And then now, if you see right from the storage engine to the today's offering that they have, which is a monitoring offering, which is
Yeah.
part of the observability. They are covering a lot of good SIEM kind of a use cases. They are in the logs, they are in the metrics, they are in the event side, which is three key pillars of the whole observability. I think the journey has been fantastic. So the way they have grown organically, and they have in my mind an excellent journey for a tech company.
Yeah.
And one of the
Absolutely.
good things about it is the Elasticsearch as the storage engine is a very strong backend. As I was saying, it uses Apache Lucene, the whole inverted index as a search. But then the Kibana layer, which is a visualization layer, which also is very mature. The Logstash, which is a collection of ecosystem Logstash, and now there is a Beats, which they use for collect data. That also is a good ecosystem. And since it is open source based, you see the community very active. Uh,
Correct.
they get a lot of support. I think our today's topic is more on the Elasticsearch, because that as a backend is very solid. Many organizations use it for very specific use cases. Now it is getting generalized as well. But I think their story has been fantastic.
Absolutely, absolutely. I think they have really grown over this year and really matured and really gone horizontally and vertically in all the directions. Like you said, observability is like a verticalized solution almost, from their perspective. So yeah, I think from a mere search engine to this level. So that's great. Uh, but and then also it, when it started, right? I think it did really catch up and it did really get adopted. So I think if we roll back ourselves to the Elasticsearch days, right? I think, what do you feel? How, you experience it for a much longer time than probably me. So why it started getting adopted? What was the real use case that they address, or what are their strength points? Maybe we can go there. Yeah.
Absolutely, absolutely. So the adoption really started when lot of organizations were looking for the analytical data, representing data on dashboards in an analytics view, and do the slice and dice of information. So at the early stages, when it was becoming popular as an open source tool, right? Organizations and existing ecosystems already had the RDBMS data sources.
Yeah.
Uh, they had their own limitations. Every time, the whole thought process in RDBMS used to be that, hey, if you're interested in one particular data, let's index that column so that
Exactly.
you can search faster. You can do
Yeah.
a lot of group by aggregation, slice and dice of data very much faster. And that is where Elastic gave its appeal. So it
Yeah.
has a very strong storage engine, very optimized, and a very rich query interface. So which means optimized with this, you can write a lot of good dashboards and custom build. It was all started with a pure Elasticsearch as a database, right? So it
Yeah.
was a non RDBMS database. It had a very much concept of the RDBMS side as well. So the adoption was very easy,
Yeah.
and the as I was saying, right? So the whole thing was adopted quickly, a good community support. And if you see the the way adoption was increased, right? It primarily because of the whole optimizations that they got along the way. So
Mm.
as the adoption, and we will talk through about how quickly was the adoption, what were the stages where they you don't have to understand everything in Elasticsearch to use it for the first few
Right.
iterations,
Right.
and that really helped them grow quickly. But their
Yeah.
primary business started with replacing the RDBMS layer, or adding as an additional visualization layer or a view layer on top of RDBMS layer,
Yeah.
and then
In
they
fact,
kind
I have
of
seen it kind of used in conjunction with RDMS also. No traditional data in RDMS, but when you want the best kind of textual searches, then use additionally use Elastic as well. Maybe 5 6 years back, isn't it?
correct, correct,
Yeah.
absolutely, absolutely.
Mm.
Yeah, and then performance also is a key factor, and I think they use a lot of good techniques. The whole inverted index to store data, which means that each of the data, each of the slice and dice of data is indexed, so that the retrieval becomes faster. So it is kind of a write delayed read efficient system,
Right.
wherein there is an inherent delay of 1 second. That is what they say,
Mm.
which requires for writing a larger data and then also replicating and all that. But that way, whenever they query, I think with a varied data sets on a large set of data, they can do an excellent analytics group by bucketing
Mm.
kind of a queries.
Mm. Right. I think a lot of our viewers will be used to using RDBMS more than maybe Elastic, and this is one key difference that you called out, that 1 second delay, which they actually through documentation they call it out, because in RDBMS you're used to ACID transactions, right? And
Correct,
the
correct,
transaction doesn't return unless it is really committed, and the next time it's immediately
yes,
readable. I think this is one difference as a designer one has to keep in mind essentially. Yeah. Right.
absolutely, absolutely.
Right.
So for real, what should I say, real time systems, I
Mm.
think we have to consider some of these factors
Mm.
while choosing the right data stores.
Correct. Correct. Yeah. Okay. And because we are talking about RDMS, let's say, I think if we try to understand a bit more about Elasticsearch, right, how it is designed, and just it's probably easier for someone to start comparing first with database, and Elastic, thinking of Elastic as a database. So traditionally, we have seen RDMS architecture, say Postgres or Oracle, right? They revolve around maybe a single machine, a bunch of processes which are running there, and they need a very strong host and server machine, and they perform fantastically on that host. As against that, now of course there is an exception of new modern databases like CockroachDB, etc. But if I look at Elastic and how they have designed it, in a true distributed fashion compared to RDBMS, I think that architecture is really different, right? And something that one has to understand very well, right? How they are designed. So maybe that's an interesting
Correct.
thing to kind of dig into a bit more, right?
Absolutely. So, as you rightly said, right? So there was a lot of hardware requirement and performance requirement that the RDBMS demanded,
Yeah.
whereas that was appealing point for Elastic, because whenever you are making a start, I need the start to be simpler. But at the same time, I want to make sure that as I mature into my use cases, I should be able to add more capacity, more performance helping hardware as well, because finally the performance will come from hardware as well. And Elastic kind of address these both needs. So Elastic actually has a very what they claim to be a very distributed database, and which means that you can add nodes on the fly, and you can kind of make use of that as well. And but you can start with very small footprint and keep on increasing as well. So at a core, they have what we call it as elastic cluster, right? You can create a cluster, and cluster is obviously formed of multiple hosts or multiple nodes. And then there is a logical concept of index, which is like a table mapped to the RDBMS world. And that index is now stores when the documents are getting written in that index, it goes into the various shards. So each index is then logically divided into the multiple shards.
Multiple
And
shots.
then there
Yeah.
are what we call it as a primary shards and replica shards. And these shards are what get stored in the node. So one index may potentially have data across multiple hardware nodes.
Right.
That gives them benefit of redundancy, benefit of the performance, so that whenever query are going, they can look into those primary shards and retrieve data and return back to the users.
Yeah.
So that's actually the four layers, what we call in a cluster. The cluster have multiple nodes. Multiple nodes logically form an index, or that index is, sorry, formed by multiple shards, and those shards are what you have on the nodes, physically stored on the nodes. So that's the high level structure, but that gives them a lot of performance uh, benefits basically.
Yeah, so that means they have figured out, even though the data is distributed across nodes, when I'm actually querying it, there is that intelligent logic to actually gather it from various nodes and form it and return it
Absolutely
back, right? And I think this query we will kind of dig deeper a little later, but I think that is one benefit that is there. And secondly, like you really called out, scalability, right? Adding a node and making Elastic aware of it is a very easy process, right? It's kind almost
correct.
seamless from that perspective. I don't have to
Yeah,
take down
yeah.
the server processes and start again and things like that. So yeah.
Absolutely. And they have again developed ecosystem exactly targeted for these kind of use cases. So for example,
Right.
they have a lot of tooling and utility support because data is now sitting on one node. When you
Yeah.
add more nodes, you want to make sure that you distribute the data further, distribute those shards further. So they can rebalance those shards to a different uh, node. And that way,
Correct.
all these background activities can happen while the cluster is still up and still serving the data. So that way, even the things that we deal with once the Elasticsearch is in the system, right? So as
Hmm.
we mature our own use cases, as we add more and more data, more and more indexes, edit those indexes, all that, there is a reindexer utilities. There are a lot of matured utilities, and over a period of time, these people have enhanced those utilities and made those production grade as well, which is a very
Hmm.
beneficial for the operations persona. Because as we move into the DevOps persona, right, it is important that I develop my own utility and also make sure that I operationalize it, manage it, maintain it. So that way,
Hmm.
that whole ecosystem, they are actually taking very good care about it.
Okay. Yeah. Yeah, that's great. And as you look at this architecture, that we're talking about and that you described, I think as we realize, I think index is again one of the most important concept there, right? Because index is
Correct,
not just
correct.
storage. I mean, it helps you performance and into performance and everything, but they also have tied many other things to index in terms of policies and how you archive and all that, right? On this
Yes,
concept. So
yes,
this whole index
absolutely.
management is an interesting concept, and maybe we can talk a bit more about that.
Sure, sure. So the whole index management is much different than what a table management, right? So RDBMS table management as such, there was not lot many things that you could really do. But at the index management, you can actually, as you said, there is what we call it as index lifecycle management policies, ILM policies, which
Hmm.
tells you that these index is backed by how many shards. So that I think is the index configuration, index template part of it. But the
Yeah.
lifecycle management is more like when index grows beyond the size, create a new index. If it grows beyond certain days, create a new index. And the way we access the data in an index is the recommended way is through alias. So alias can point to one or more indices. So it is a pattern. So if I'm creating an index saying that, hey, Amit's production data, and then I can say Amit's production data one, Amit production data two, three, and stuff like that. And I
Hmm.
can create a alias which will say that Amit production star, which means from one, two, three, all of it. When I'm firing a query against this alias, I
Right.
will be looking data across all three. So the standard way to create these or aliases is there is a read alias, which is covering all the necessary breadth, and then
Yeah.
there is a write alias, which is always writing to the latest and greatest.
Mm.
So that way, the life cycle policy I can dictate, and there are various use cases to select which policy, but the most prominent is the size based policy. They
Right.
typically recommend that when an index grows certain level or a shard grows certain level, it is always good to create a new shard, which means new index. But then the purpose of the index, the mapping of the index, the metadata of the index, everything remains same. So then that is the policy I define. Hey, I want my index to not to grow beyond 100 GB. Once I reach that size, start a new index. Adjust my aliases such that when I read from all my indices, but when
Yeah.
I write to the latest one.
Right.
And then I can define after, let's say, 3 months, archive the current index, delete
Mm.
the old index basically,
Mm.
delete the old index and all that. So I can define those windows that which is my active index to be written, which are my read indices, and which are the indices in the past that I may
Right.
have to archive, delete, and such that. That is the
So
whole life cycle around the indexes.
right. And like you said, I think absolutely. So one is it helps in archival, but it's probably also helps you control the size of the physical file, because finally index is what maps to a
Absolutely.
physical storage unit, right? And you want to optimize that so your
Correct.
queries are also optimum and things like that. I assume even that is also the case.
Ab-
Uh,
Absolutely, that is
yeah.
definitely the case, and that also helps them to do certain things, which is archive and restore and stuff like that.
Hmm.
Because then they can get that section which they can archive, and
Hmm.
then they can restore it in a delta data fashion. So
Right.
they create what we call it as a snapshots of those
Yeah.
shards and indices, and then they can easily restore the snapshots. So the data continuity is there. Plus, there is a delta data feature, which you can say that, hey, the first snapshot is the actual big size. Beyond that, each snapshot, I can take snapshot every day, every week, every month, etc. But beyond that one first big snapshot, the rest of it can be the delta snapshot. And the
Hmm.
restoration order is also the similar fashion.
Yeah, I think this is great. I mean, for a person who's coming from our RDBMS background or even NoSQL background, I think this is a very different concept that one has to understand, because how you design your indexes, based on that, many other use cases will become easier for you, later on, essentially, and
Absolutely.
also you will be
Absolutely.
able to ensure right performance, right backups and things like that. But yeah, okay. So
Yes.
now that, yeah, so now that let's say I have these indexes, now the question is how does the data come in, and when the data is coming in, right, into the system for the Elastic. Now, so what are the next stages for that actual data? Like when the documents go inside the index, how do they get managed and all that? That's the next topic, right? So that it kind of set the
Absolutely.
stage for searching, essentially.
Correct. Correct. So this is where the whole schema part comes in, right? In RDBMS,
Hmm.
we define that schema.
Yes.
Here we call it as a mapping or mappers.
Hmm. Okay,
And
mappers. Yeah.
Elastic, I think, has done a fantastic thing that they have said that, hey, uh, you don't need to know everything upfront. So they have a concept of what they call as a dynamic mappers, which they define a dynamic template in which say that, hey, so basically Elastic again is a JSON database. It
Correct.
accepts JSON, it gives back as output of a query as a JSON as well. So it is all JSON DB. And then JSON is so flexible for users because they can keep on adding to the JSON without worrying too much about the actual syntax or schema and stuff like that. Obviously, that is a lenient way of reading, parsing, and writing JSONs. But that is what Elastic has kind of embraced. They have a
Right.
concept of mappers, and they have further gone ahead and introduced a dynamic mappers. In which
Hmm.
case, you don't need to exactly specify what are your key names. You just say that, hey, whatever JSONs you documents that you ingest, you can
Hmm.
create those as your columns or the keys,
Okay.
and then Elastic itself will maintain that mapping because that mapping is a generic enough. So it can be string, it can be integer, it can be any of those various data types that it supports.
Hmm.
But then it is very easy because you don't have to really think through before ingesting data. Obviously, there are pros, cons on each side. So
Right.
dynamic mappers is what gave a big push for Elastic's adoption, Elasticsearch adoption. because that made developers' life very easy. So all
Right.
POCs, because we finally start with POCs, right? When we are looking at performance improvements, whether I'm quickly show that performance improvement. And with that template, it took away the original setup time or the time to embrace, time to test and do a quick POC. And even in lot of use cases, it is required because I'm ingesting data from my customers, and that data can vary.
Right.
The variations can be on a larger scale or a smaller scale, but having that dynamic mapping templates is a huge plus in multiple such cases. Obviously, the performance side, it is still not fully optimized because it has to be generic enough. So for performance, they do have a very powerful static mappings wherein you can define explicit types, whether it is a number or integer or a text or binary boolean,
Yeah.
date. Then there are objects, nested JSON, and some of the special types like keyword and all that. I think we'll cover about it, what that
Right.
means in. But all these would be very much required because based on these types, the processing is required, how I'm indexing data. Finally, the
Right.
efficiency of Elasticsearch will come from how good the indexing has happened and how
Correct.
easy it is to search. So that is where
Hmm.
the static mappings really shine over dynamic
Okay.
mappings because
Okay.
it's a
Right.
purpose built.
Purpose built, and hence there is enough metadata for Elasticsearch to kind of then go ahead and optimize the searches, indexing and everything right after that.
Absolutely, absolutely. So
Hmm.
Elasticsearch has a huge metadata system. So
Yeah.
it is one of the more matured products where they have actually, so to an extent, when a new person takes a look in it, right, to the extent that they get overwhelmed, saying that, oh, do I have to learn all these things? And
Yeah.
it becomes very difficult. That will I be real an expert in Elasticsearch? And you don't need to. I think the good part about Elasticsearch is both spectrums exist and they exist very well. There is a very simple use case which you can really quickly do and then get away with your current problem. And then there are very specific performance as you increase your system, as the data grows, as the use cases grow, the complexity grows. There are very specific mappers. Uh, Again, so the metadata, if you just look through their documentation and just go through the
Right.
index of things to read, it is
Yeah.
absolutely overwhelming.
Absolutely. Yeah.
So
I think the first time I
the,
looked at it, I was also like, overwhelmed. Oh, where do I start? When it comes to
no,
that mapping.
I
So,
still absolutely I still get overwhelmed. So I
yeah.
every now and then I need to go back and refresh because I've
Correct.
read about it, but then you don't practice, then you tend to forget, and it is
Correct.
absolutely normal. So that
Right.
way the documentation is good, but
Good.
yeah,
Yeah.
they have very powerful metadata driven system.
Correct. Correct. So I think whoever is kind of trying to adopt and learn Elasticsearch, and this is a point to keep in mind that don't be too much worried. That there's a lot there, but great documentation, great examples which you can try yourself for both dynamic and static mapping. So okay, and
Absolutely.
so yeah, and then comes the whole question of now that my data is coming in, I have indexes set up, and I have a lot of textual data which is coming in, right? And that is one of the key power of Elasticsearch, right? How you can really search on textual search. No comparison when it comes to RDMS. I feel always right. That we can talk about a bit more, like how it analyzes the data, textual data, especially and other kind of data. So that's also interesting point. Yeah.
Correct. Correct. So this is where the specialty of Elasticsearch comes in,
Hmm.
wherein we are saying that, hey, with these incoming data, with those mapping templates defined, right? What are the things that I have to look for increasing my performance? And then that goes back to what you want to do with the data, how you want data to be processed. For example, do you want to parse each and every string, and then, or you can say that, hey, I am storing, let's say, again, just to give an example, right, email body for whatever use
Hmm.
cases, right? So again, may not be
Yeah.
the best use cases. So let's consider a raw JSON. So
Yeah.
in the raw JSON, there are logs. So let's consider logs as a very valid use case, right? I'm looking
Mm-hmm.
for logs. I'm looking for specific strings, and then I can say that, hey, I may not need some specific data like English words, a and the and all that. I can skip
Correct.
all those terms, and then I can skip some of the special characters. Or in fact, I want to store everything as a lowercase because when I search, I can search with it. All these are how do I parse that data? And in the mapping, there is a lot of metadata, but two things I think I want to call out here. One is the analyzers, and analyzers are backed by the tokenizers.
Hmm.
In Elasticsearch, these are the two things which come in the picture while writing the data. So they parse the incoming data, create what we call it as a tokens or terms, and then stores that data in an index. So for example, analyzer is backed by a tokenizer. Now in combination, these two decide, so how do I want to split my string.
Right.
So if there is a really big string, I can use a special type of a tokenizer, which is like a keyword, which says
Hmm.
that, hey, do not even attempt to parse it. So you can still query for it, search for it, but then I need the full string to get in. So it's like a no-op tokenizer. If I
Right.
just specify keyword or
Hmm.
a type as a keyword, then it's
Hmm.
kind of a no-op one. But then there are very generic one, which is like a white space. So if I store two strings separated by white space, then what the Elasticsearch is going to do, it is going to parse. Whenever it hit white space, it is going to create those tokens.
Right.
So then I can create those as my search terms, and I can say
Right.
that, hey, Amit Subhedar, I can search with Amit, or I can search with Subhedar, and I will get the things as well. So it
Right.
is based on those tokenizers. These are the standard one.
These are
So
the standard
in
one.
most
Probably
of
the
the,
most
yeah,
common. Yeah.
most common ones, you don't need to
Yeah.
even read about these. By default, these are there. So for example,
Right.
classic tokenizer, you don't need to read. It will do
Yeah.
special character tokenization. It will do the white space tokenization and stuff
Hmm.
like that.
Yeah.
But then there are few ones which is like ngram. Ngram is
Yeah.
where we'll say that, hey, I am again, Amit Subhedar is an example. Then I'll say that if I write sub, will I be able to get it? If I write bhe, will I be able to
Hmm.
get Subhedar out of it?
Hmm.
So, and then this is where the ngram tokenizer comes in. So minimum they say that keep a character length like 3. Don't
Three.
go reduce it,
Correct.
because otherwise there will be too many terms or too many tokens, and that increases the even the storage disk and whatnot. So there is always a balance that we have to look for.
Hmm.
Now these ngram tokenizers will say that Amit Subhedar, they will say AMI, MIT, and then SUB, UBH, UBD.
Hmm.
Likewise, they will create those terms, and they will create those and store it. So that
Yeah.
if I just say BHE, I am going to get my column and the data in it. And then there is ngram edge, which is like, don't search for BHE, because then there are so many terms, right?
So
If you
many.
just look at
Yeah.
the Subedar, it will
Hmm.
create so many terms. But then
Correct.
edge is will tell you that only do it with the start. So I'll say
Right.
SUB, SUBH, SUBHE, SUBHED. Likewise,
Right.
they will create a term so that they will
Yeah.
match those.
Right.
And that becomes the efficiency. That is where the write
Correct.
inefficient and read efficient system comes in. That
Hmm.
while writing, they will create so many terms and so many tokens, so that when they read, when a query comes in, and if a query gives SUBH, and they are going to match these details.
Okay. Right. Okay. Perfect. So now that we have power of index, and then we also seen the power of how analyzers and tokenizers work, and our data is now crafted in, created in, right, and all well distributed. Now it's time to query that data. So I think let's talk more about that whole DSL and the power of DSL, the filtering, and so many things we can do with that, right?
Yeah. So this area is, in my mind, one of the very tough areas, and this also comes lot of Elasticsearch specific knowledge. So
Yeah.
this is a different query language. Obviously, they have what they now recently released as an event query language, and the SQL version of it as well. But then the DSL has the maximum feature, the domain specific language, the
Yeah.
Elasticsearch domain specific language.
Yeah.
And then this is where there is a lot of query support. So standard query for filtering, you can write with a match criteria. Then there is a query criteria like with a Boolean filter outside. You can mention terms like must, should not, and all that. And the simpler part is query and query string. Again, it is hard to explain in a session like this, but then there is a very strong documentation available. There are good examples and a very strong community available around it as well. Uh, these queries are the one which will give you the normal use cases in a much better fashion. For example, things like for dashboarding, you would need those aggregation.
Hmm.
You would need those histograms or date histograms
Right.
or various term queries. And you can search for those terms. You can group them together. You can plot a timeline. You can do a trending, you can find out the whole analytics around it. And there is a specific query type, there is a specific metadata available. Even in the response parsing, you can actually highlight the terms, and that you can specify in the query. So
Yeah,
this again
correct.
goes back to Elasticsearch being a huge metadata driven system.
Yeah.
Even at a query, it is so exhaustive
Mm.
that you need to look for those use cases, and then you will have to find out that which are these use cases which I need, and accordingly, is there a flexibility in Elasticsearch that is available that I have to use and find. So uh, I would say start with the simpler queries, experiment it, and then
Right.
really look for some Grafana backed queries, sorry, Grafana or Kibana backed queries,
Kibana backwards,
wherein
yeah.
these dashboards will give you a lot of insight into what are the patterns, how they have built it, what kind of a
Mm.
histograms, what kind of a term query they have built. That
Mm.
way, in my mind, the learnings can be quicker.
Yeah, no, absolutely. I think DSL probably is a topic by itself, topic
It is
for some other
absolutely a
day.
topic.
And so is
Absolutely,
Kibana.
absolutely.
Absolutely, yeah. I mean, extremely
Correct.
powerful, feature and extremely powerful tools like Kibana, to make full use of that, basically. Yeah. But yeah, I think that's for another day, and I'm sure that gives me opportunity to again call you back, Amit, here. But yeah,
Absolutely, would
but
love to.
yeah, yeah, I think you've brought in the whole power of Elastic, very well in this discussion. But I think before we kind of conclude on this, I think most important thing is also to call out for our viewers what they need to be aware of if they are trying to adopt Elastic. I mean, things are not always rosy. So, what from designer perspective, what one should be aware of, and maybe I think that's something you
Yeah,
can help call it out. Yeah.
definitely. So I would say use cases. So that's number one, not just with Elastic, but for any other thing, right? Now we are in an era wherein we have specific tools available for specific use cases, and nobody's forcing us to use one tool to do all the use cases. I think that
Mm.
is where we stand as an industry, wherein we
Yeah.
are more focused on purpose built. So look for those use cases and try to use as native capabilities of Elasticsearch. Customizations are excellent, and there
Right.
it gives you a lot of flexibility for customizations as well. But
Mm.
then you will have to also be ready or understand the performance. So I would say focus on use cases, focus on your actual data characteristics, the query use cases, the query characteristics, what kind of a visualizations that you need for your data. I think that would be really
Mm.
crucial. And then I would say as data increases, some of the key parameters that you have to look out for is also the cluster performance. How do I monitor, maintain the overall DevOps around it? What are those
Yeah.
key performance matrices other than the standard infra one, like the JVM memory pressure and all that? That gives a
Right.
lot of insights. That's again for a much advanced discussion later. But
But we have
those would be,
actually seen in real life that if you don't do that, then what happens, right? It can bring down your
we
whole
have heard
system or it
the,
will
yeah, we have heard the hard way, but
hard
I
way.
think that's still
And
learning.
that's
Yeah.
why
So I think
right thing to call it out. Exactly. Yeah.
absolutely, absolutely. And
Yeah.
then the docs and
Docs.
the
Yeah.
ecosystem is very powerful. Community is
Yeah.
very powerful.
Correct.
Do read, do experiment,
Yeah.
do create those visualizations. I think this would be uh,
Perfect.
this is actually one of the awesome industry standard tools to learn.
Yeah. Very true. Very true. Okay, great, great. So, viewers, I think this was absolutely an enlightening session for you as well. I mean, it has been for me, even though I've used Elastic a bit. I think there is so much to it that you would not have used or would not have experienced. And thanks, Amit, for coming here, spending time, and taking us rapidly through these topics. This will surely help many viewers to start learning, and I'm sure I think we can share certain resources which people can look at and learn further from that. This just becomes the intro session for them, right?
Absolutely. Thank you very
Yeah.
much, Samir. This has
Okay.
been again one of my achievements to be appear in this your channel and show. So I'm really thankful
Yeah.
for
Yeah.
inviting and looking forward for more such
Looking
discussions.
forward for more sessions, Amit. Absolutely. And thanks everyone. And bye. Keep
Thank you.
watching. Bye bye.
Thank you. Bye.
Thank you. Bye.